Hello, my name is Milo and I will be talking today about induction. Induction is a mathematical proof that takes 3 steps. Step 1 is finding a base case. For some equation p of n that we will be inducting upon, the lowest element in p of n holds. The lowest such that, meaning the lowest element in p of n will produce an actual result. So, in the case that p of n resides in the natural numbers, we say that p of 1 holds, since 1 is the lowest element in the natural numbers. Then, after this, we show that p of k holds for some arbitrary element in the natural numbers. After this, we show that p of k plus 1 holds. And showing that p of k plus 1 holds requires some assuming that p of n is true, and assuming that p of n plus 1 is possible by showing it, and we are showing that since p of n is true, it implies that p of k plus 1 exists. So, to do this, let's go through an example. Let's say for all n greater than or equal to 1, 3 divides 4 to the n minus 1. Now, since we want to show for all n that is greater than 1, we show that we want to show that n is greater than or equal to 1, we know that the lowest possible element that this can be is 1. So we want to show a p of n. So for the lowest element would be p of 1. So we show that p of 1 in this equation would be 4 to the 1 minus 1, which equals 3, which is divisible by 3. Now we know that the base case is true, so then we assume that for some k, 4 to the n minus 1 equals some 3k, for some element k. We can use this because then we know that p of n, we want to find p of n plus 1. P of n plus 1 will be equal to 4 to the n plus 1 minus 1. And we can rewrite this as 4 times 4 to the n minus 1. And since we know that 4n is equal to 3k plus 1, since we can do some rearranging on this equation, so then we can find that 4 times 4n minus 1 is equal to 4 times 3k plus 1 minus 1. And if we expand this, we get 12k plus 4 minus 1, which is equal to 12k minus 3 plus 3. And we know that we can take out a 3 and get 4k plus 1. And we know that 3 is obviously can divide 3 times 4k plus 1. So then, at the end of the proof, we say, thus, by mathematical induction, we've proven that 3 divides 4n minus 1 for all n greater than or equal to 1. And then we have our proof has been solved square, and we have correctly proven through mathematical induction that for all n is greater than or equal to 1, that 3 divides 4 to the n minus 1. Thank you.